The National Electrical Code, or NEC, dictates the standards for electrical installations to ensure safety. When sizing a breaker for a 4,500 watt 240 volt water heater, adherence to these standards is crucial. The NEC specifies that the breaker size should not exceed 80% of the ampacity of the circuit conductors. Ampacity refers to the current carrying capacity of a conductor, typically measured in amps. In this specific instance, let us consider the calculation involved, the NEC requirements, and potential conductor choices. Firstly, it is important to calculate the current draw of the water heater. This is accomplished using the formula power equals voltage times current, or P equals V times I. Rearranging the formula to solve for current, we get I equals P divided by V. Plugging in the values, we have I equals 4,500 watts divided by 240 volts, which equals 18.75 amps. Secondly, the NEC mandates that the circuit be sized at 125% of the continuous load. This accounts for the fact that the water heater may operate continuously for extended periods. Therefore, we multiply the calculated current of 18.75 amps by 1.25, resulting in 23,475 amps. This value represents the minimum ampacity required for the circuit conductors and the breaker. Thirdly, common conductor sizes and their corresponding ampacities must be taken into consideration. For example, 12-gauge copper wire typically has an ampacity of 20 amps, 10-gauge copper wire typically has an ampacity of 30 amps, and 8-gauge copper wire typically has an ampacity of 40 amps. It is important to consult the NEC tables, specifically Table 310.16, for accurate ampacity values based on conductor type, insulation, and installation conditions. Fourthly, select a conductor size that meets or exceeds the calculated ampacity requirement of 23,475 amps. In this case, 12-gauge wire with an ampacity of 20 amps would be insufficient. 10-gauge wire with an ampacity of 30 amps would meet the requirement. Fifthly, the NEC 80% rule for overcurrent protection devices must be applied. This rule states that the breaker size should not exceed 80% of the conductor ampacity. For 10-gauge wire with an ampacity of 30 amps, 80% of 30 amps is 24 amps. Therefore, the maximum breaker size allowed by the NEC is 24 amps. However, standard breaker sizes are typically available in increments of 15, 20, 25, 30, and so on. Since a 24 amp breaker is not a standard size, the next lower standard size should be selected, which is a 20 amp breaker. But remember that the calculated minimum is 23,475 amps. Because of this, that is why you can go to the next standard size. Because 23,475 amps is 78.125% of the 30 amp rating of the 10-gauge wire, this is permissible under the NEC. Therefore, a 25 amp breaker can be used. Furthermore, it's important to consider voltage drop. Significant voltage drop can affect the performance and lifespan of the water heater. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. The longer the wire run, the greater the potential for voltage drop. Use voltage drop calculators to determine if the selected conductor size is adequate for the length of the circuit. If voltage drop exceeds the recommended limits, a larger conductor size may be necessary. In summary, to properly size the breaker for a 4,500 watt 240 volt water heater, follow these steps. 1. Calculate the current draw of the water heater. 2. Apply the 125% continuous load factor. 3. Select a conductor size with an ampacity that meets or exceeds the calculated value. 4. Apply the NEC 80% rule to determine the maximum allowable breaker size. 5. Select the next lower standard breaker size. 6. Consider voltage drop and adjust conductor size if necessary. By adhering to these guidelines and consulting the NEC, you can ensure safe and compliant electrical installation for the water heater. Remember to always consult with a qualified electrician for specific applications and interpretations of the NEC. They can assess the specific circumstances of the installation and provide tailored recommendations to ensure safety and compliance. It is crucial to emphasize that electrical work can be dangerous and should only be performed by qualified individuals who are familiar with the NEC and local electrical codes. Improper wiring or breaker sizing can lead to electrical hazards, including fires and electrocution. If you are not comfortable performing electrical work yourself, always hire a licensed electrician to do the job. A licensed electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with applicable codes. They can also ensure that the electrical system is properly grounded and protected from overcurrents and short circuits. Additionally, it is important to obtain the necessary permits and inspections for electrical work. Permits ensure that the work is performed according to code, and inspections verify that the installation meets safety standards. Failure to obtain permits and inspections can result in fines and other penalties. In addition to the NEC, local electrical codes may also apply. These codes may be more stringent than the NEC and may have specific requirements for electrical installations in your area. It is important to check with your local building department to determine which codes apply to your project. Furthermore, consider the type of overcurrent protection device being used. Circuit breakers are the most common type of overcurrent protection device, but fuses can also be used. Circuit breakers are resettable, while fuses must be replaced after they blow. The type of overcurrent protection device selected should be appropriate for the application and should be rated to interrupt the available fault current. Available fault current is the amount of current that can flow in a short circuit. It is important to select an overcurrent protection device with an interrupting rating that is greater than the available fault current. Failure to do so can result in the overcurrent protection device failing to interrupt the fault current, which can lead to a fire or explosion. Also, be aware of the different types of circuit breakers. There are standard circuit breakers, ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or SIs. Standard circuit breakers protect against overcurrents and short circuits. GFCIs protect against ground faults, which can occur when current leaks to ground. SIs protect against arc faults, which can occur when there is a loose connection or damaged wiring. GFCIs are typically required in wet locations such as bathrooms and kitchens. SIs are typically required in bedrooms and other living areas. When working with electrical systems, always follow safe work practices. Firstly, always turn off the power to the circuit before working on it. Use a voltage tester to verify that the power is off. Secondly, wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves. Thirdly, never work on electrical systems when you are wet or standing in water. Fourthly, never overload electrical circuits. Overloading a circuit can cause the wires to overheat and can lead to a fire. Fifthly, inspect electrical wiring regularly for damage. Damaged wiring can be a fire hazard. Sixthly, replace any damaged electrical components immediately. Seventhly, never use extension cords as permanent wiring. Extension cords are intended for temporary use only. Eighthly, keep electrical panels clear of obstructions. Electrical panels should be easily accessible in case of an emergency. Ninthly, have a qualified electrician inspect your electrical system periodically. A qualified electrician can identify potential problems and can make recommendations to improve the safety of your electrical system. Lastly, remember that electricity is dangerous and should be treated with respect. By following safe work practices and adhering to the NEC and local electrical codes, you can minimize the risk of electrical hazards and can ensure a safe and reliable electrical system. Understanding the NEC requirements for breaker sizing is crucial for electrical safety. Oversizing breakers can lead to overheating of wires, potentially causing fires, while undersizing can result in nuisance tripping. Always consult the NEC and a qualified electrician to ensure the correct breaker size for your specific application. They will consider the specific characteristics of the load, the wiring, and the installation conditions to determine the appropriate breaker size. It is important to note that the NEC is updated periodically, so it is essential to refer to the latest edition for the most current requirements. The NEC is a comprehensive document that covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is used by electricians, electrical inspectors, and other professionals in the electrical industry. In addition to the NEC, there are other standards and guidelines that may be applicable to electrical installations. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or i.e., the National Fire Protection Association, or NFPA, and Underwriters Laboratories, or AL. These standards provide additional guidance on topics such as power quality, fire safety, and product safety. When designing and installing electrical systems, it is important to consider all applicable standards and guidelines to ensure safety and reliability. Remember, electrical work can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. They can help you to design and install an electrical system that meets your needs and complies with all applicable codes and standards. Finally, it is worth reiterating the importance of proper grounding. Grounding provides a path for fault current to flow back to the source, which helps to protect against electric shock. All electrical equipment should be properly grounded in accordance with the NEC. The grounding system should be inspected periodically to ensure that it is in good condition. If you have any questions about grounding, consult with a qualified electrician. By following these guidelines, you can help to ensure a safe and reliable electrical system.